guys, so we're going to get into the heart of this part of Chapter 7. Chapter 7 is super short, but then it kind of dovetails into something from Chapter 8. So what we're going to be doing is we're talking about equations, and so we're going to be focusing in on solving equations the proper way. So some of you guess and check. A little bit like 7-1 is, we never get to do that anymore. We're going to solve because we need to learn the process in order to be successful from here on out when we have equations. So we're going to call this lesson Solving Equations Using Addition and Subtraction, or Subtraction. So in order to do that, I do need to explain to you something called inverse operations. So these are the kinds of problems we're going to be solving. Now they could also involve fractions or decimals. Okay. All right, so what do I mean by inverse operations? So inverse operations are operations that undo each other. Okay, so that's kind of an interesting word. But basically we're going to do an operation to get rid of something by undoing it. So for example, when I have an adding problem, I'm going to use subtraction to undo it. And vice versa, if I have a subtraction problem, I'm going to use addition to undo it. And then if I have multiplication, I'm going to use division to undo it. And that's going to be the majority. We generally don't see the other direction. If I have a division problem, I'm going to use multiplication to undo it. Okay? Now, this lesson focuses in on the green. Adding is undone by subtraction. Subtraction is undone by addition. Okay? Now, there are a couple strategies. If you look at your book, it shows you how you can use models and you can take stuff away. But here's what I want us to get from this idea. We need balance. Must have a balance when solving equations. Okay, so when I'm talking about balance, I'm talking about what I do to one side of the equation, I have to do the same thing. So I'm going to say here, treat both sides of the equation. Now when I talk about both sides, I'm talking about to the right and the left of the equals. Treat both sides of the equation, I should say equation, not equations, the same. So if I add 2 to one side, I'm going to add 2 to the other. That maintains balance. If I don't do that, then actually my equation is off kilter. The answer I get won't be true. If I substitute back in, I'm going to get something that's false. Okay? So I'm not going to take time and talk about the strategy of drawing pictures and diagrams and things like that. We're going to go right into the heart of the matter. So we're going to use the idea of inverse operations. So our method is going to be use inverse operations. So we're going to undo things. Okay, so let's start with that first example at the top. X plus 3 equals 7. So what I want to do is to get the x by itself. That's the whole job. That's the whole job. So I'm going to write that here. Get variable alone on the left. Okay, that's our job. So it's going to be variable equals answer. That's how it's going to end up, okay? And then, so, if I want to undo addition, I would use subtraction. And what I'm going to subtract is whatever's on the same side of the variable, okay? So if I do that on the left side of the equals, I got to do that on the right side. Otherwise, I lose balance. Now, what happens when I add 3 and negative 3? If I add opposites, I get 0. What do I get when I add 0 to anything? Identity property of addition says you get that thing, so you get x. And then we do the math on the other side. 7 take away 3 is 4. Now, what I just used is what's called the subtraction property of equality. Subtraction property of equality. So when I have an equals sign involved, I have an equation, and when I subtract the same number from both sides of the equation, that's the subtraction property of equality. Now, what I can do is check to make sure my math is right. How? I'm going to take my answer I get and substitute it back into the original problem and see if what's on the left ends up equaling what's on the right. So 4 plus 3 is 7. 7 equals 7. So that says, yep, x has to equal 4. Now, I know what some of you are going to say. I could have done this in my head. Why do I have to show my work? Because I'm teaching you a process that's going to help you solve much, much, much more challenging questions. All right, so let's kind of put in bullets. What did we do? Our job is to get the variable alone on the left. And when I'm saying left, I'm going to say of the equal sign. That's what I'm referring to. And then I'm going to say do when I wrote 2. Let's try that again. Do inverse operations. So opposite to what's currently going on in the problem, doing inverse operations. On both sides of the equation. So what happens is that the problems get increasingly more challenging every single year. So there's going to be parentheses added in, and you're going to have to distribute, and then you're going to have combining like terms, and then you're going to have to get variables on the left, constants on the right, all sorts of big stuff, but we're just starting easy right now. And when I do inverse operations, I will get these kinds of numbers, which are called opposites. So opposites, and their sum is 0. That's always true. All right, let's talk about that other one we had at the top. X minus 7 equals 15. So the inverse of subtraction would be addition. So I'm going to add 7. It's always the number that's on the same side as the variable because I want to get the variable alone. So this is called the addition property of equality. Okay, and what happens? I have opposites, so they add up to equal 0. Identity property of addition says when I add 0, I get that number, which happens to be our x, and then 15 plus 7 is 22. So we're going to check our work and see if 22 minus 7, ooh, that's a terrible 7, there we go, does that actually equal 15? And we go, yeah, let's see. 12 take away 7 is 5. 1 take away nothing is 15. It works. and therefore we have the correct answer. Okay, so that's the method we're going to be using, inverse operations. No guessing the number. You do that, you're not going to get credit on the homework because you're missing what you're being asked to do. All right, let's get some practice in. Okay, so our directions are going to ask us to solve each equation and then check the solution. Each equation. Now, everybody's like, why do I have to do this? So I'm just going to tell you the reason why you check your math. Who do you want to figure out that it's wrong? You or me? If you figure it out, then you can correct it before I get to see it. If I'm the one who has to do the correcting, you're going to lose points. Simple as that. So we're going to do a couple of different weird problems. So we have 8 equals x plus 3. But remember, it's supposed to have the x is supposed to be on the left. So we're going to use something. I'm going to teach you the name of a property. It's called the symmetric property. And it's just another property that allows us, it's actually of equality, it allows us to pick up and rotate what side those problems are on. Okay, so I like to do that before, but you can always do it at the end. And we're going to pick up the x plus 3 and write x plus 3 on the left, pick up the 8, and we're going to put on the right of the equal sign. Now, remember, the answer says you have to put the variable first, because that's what you're solving for. You're not solving for a number, you're solving for the variable, and the variable will equal a number. Okay. Then I notice we have addition, so we're going to use subtraction. That's subtraction property of equality. We get 0 here, so we just get x, and then 8 take away 3 is 5. So then we're going to check. And I always go back to the original problem. So 8, does that equal 5 plus 3? And the answer is yes, it does. So that verifies we did it right. Number 2, decimal. 3.5 plus y equals 12.75. So what you're going to do is you're going to look at the number that's doing math with the variable. And if you notice, it's a positive number. So we're going to do the inverse of that. We're going to do a negative number, which is the same as subtracting. So remember, with decimals, we line up decimal points, annex zeros, so they both have the same number of digits after the decimal point. These are opposites, so you get 0. You're left with y equals, and then we do our math. So decimal point stays in place. 5 take away 0 is 5. 7 take away 5 is 2. 12 take away 3 is 9. Okay? So I'm going to check that. And I want to know if 3.5 plus 9.25, does that actually equal 12.75? Okay? So I'm going to line up 3.5 underneath here. I get 5, I get 7, I get 12, and sure enough, it equals. So that just proves that y has to equal 9.25. So let's go ahead and do a problem with a fraction. X plus 1/3 equals 5/6. So the inverse of adding 1/3 would be subtracting 1/3. Now the problem I run into, my denominators don't match, so I'm going to have to create new denominators. Since 3 goes evenly into 6, I'm going to keep 5/6 the same, but I'm going to turn the denominator of the second fraction into a 3. a 6, it was a 3. So I'd have to multiply top and bottom by 2. So that would give me a 2. So I'm going to subtract 2 6 from 5 6. And I get x equals 3 6. But remember, with fractions, we do need to simplify. So we're going to divide by 3. And we get x equals 1/2. So then, to check, I want to know, does 1/2 plus 1/3 actually equal 5 6? So I need a common denominator, which is going to be 6. Means I'm going to multiply top and bottom by 3, top and bottom by 2. So I'm going to end up with 3 6 plus 2 6. And I get 5 6 equals 5 6. So that tells me, yep, the answer is 1/2. All right, let's just do 2 more problems. Let's do one with a decimal and one with a whole number, but let's change the operation. Let's do x minus 2 equals 3. So the inverse is going to be, the inverse of subtracting is adding. I like it when it's whole numbers. It's so much easier, right? 3 plus 2 is 5. So we're going to check that. Let's see. Is 5 take away 2, is that equal to 3? So 5 take away 2 is 3. And I get 3 equals 3. So that proves my answer is 5. All right, last one. Let's do x minus 1.5, or 1 5/10 equals 76 hundredths. Okay, so it's a subtraction problem. So again, I'm going to add 1.5 to both sides. And notice I'm always showing the operation. You got to do that. You can't just write 1.5 at the bottom. You got to show if you're adding or subtracting. So, I forgot to say that equaled 0. I forgot to say that that equals 0. Sometimes I get so excited to get done, I forget my little details, huh? So over here, let's see, I get a 6, I get a 12, carry a 1, 1 plus 1 is 2. So now I'm going to check. Is 2.26 minus 1.5, does that actually equal 0.76? So let's see, we're going to do the math over here. We get a 6, we get 12 take away 5 is 7, 1 take away 1 is 0. We get that equals 0.76. That means my answer has to be x equals 2.26. There you go. All right, we'll talk about this in class. Bye now.